Hello everyone, I hope you all are doing well. This side Priya Bhatia. And in this specific video, we will be discussing about the implementation of whatever things we have learned with respect to XGBoost algorithm. See, implementation wise, you will observe that again, things are pretty much easier to understand, but I will try to showcase you the comparison between gradient boosting, random forest, and XGBoost algorithm on open source data. The main idea is to showcase you with respect to all of these three powerful algorithms, which algorithm will works the best. How can you compare whenever you are working in your project with respect to these powerful algorithms? Uh, Initially, I tried to compare it with the hyperparameter tuning part per se, and I have written the code accordingly. But the problem is that it took a lot of time to tune the hyperparameters of all of these three algorithms, and it won't be feasible for me specifically to record the video with respect to the hyperparameter tuning. Although I'll share the file with you with which hyperparameter tuning code will also be available. But in this video, I will just, as a recorded part per se, explain you how can you do that, but showcase you without hyperparameter tuning how can we able to get the results. But I will highly suggest to everyone that please do the EDA of your dataset, whatever you are working with in your industry, pretty well, followed by whenever you are applying these algorithms, please make sure that you will do hyperparameter tuning, because companies will provide you a great GPUs access, or maybe they will say to you to work in the cloud platform. That's another amazing thing. Or you can also have a subscription of Collab Pro, which provides greater GPU. So there are multiple options we have. It's just that I'm doing in a free version. So that is why I'm just showcasing you that without hyperparameter tuning, how the performance of our model looks like. But at your end, if you're working in a company, you can experiment. If you're a student, you can just experiment and understand what I'm trying to convey here. And whenever in future you will work in a company or in your research part per se, you can use that knowledge and apply that. Okay, so without wasting any time now, let's get started and we'll try to do the implementation for the same. So here, if you can see, first of all, what we can do is we can try to import all the required frameworks. Let me reconnect the file. Initially, I tried to change the runtime type to T4 GPUs, but for me, at least, currently hyperparameter tuning won't run. It took a lot of time, so I thought that let's comment that part. So here you can see I have imported all the required frameworks. Now, one important thing, it's for the very first time because we are doing the implementation of XGBoost algorithm. So you will see that to implement XGBoost, you need to specifically import it. As I said, it's not a part of a sklearn, so you can give an alias name as XGB. After that, here, just for the implementation per se, I am using the you can say open source data of fetch California underscore housing, because initially my plan was to curate hyperparameter tuning via grid search CV, so I have imported that as well. Mean squared error is to evaluate our algorithm's performance. After that, you all know that this random forest regressor and gradient boosting regressor is a part of an ensemble technique, so we have imported that as well. Now, once this is done, what you can do is you can simply load the data. If you want, you can do it step by step also. So let me just remove this part completely. So let's try to, first of all, again, do the import of the required things. So we have imported all the kind of data sets which are required. Now, after that, the next important step is to load the data and do the data splitting into training and testing. So let me just remove this complete part itself. And now if you can see, what we are doing is we are just simply trying to load the data and splitting it into train and test set. So that's what I have done here. So here you can see, if you want, I can showcase you. I think I have used somewhere in the previous part of the sessions as well this data set, if I'm not wrong. Anyhow, let me just showcase you how this data looks like. You can see that it contains lot many number of feature values, and the target is nothing but it's numeric numbers, because it's a house price prediction data. So at the end of the day, the target value is the price of the house. That's something which we have, right? Target names, if you want to explore, you can explore that. What are the input features we have? Everything is available. Description of every specific feature is available here. So you can just go and explore this part by just printing it out. Once this is done, now the next task, if you all know, is to, once the training is done, now we have to initialize the models, and that is something which we call it as a part of data modeling. So if you can see here, what I'm doing is I'm trying to use 3 models here, because I just want to see the comparison or the performance between XGB versus random forest versus gradient boosting. So here you can see we have XGB regressor. So directly you can call that. One more thing, this XGBoost algorithm is also applicable for a classification task as well. So if you want to use classification part problem per se, if you want to solve that, you will use XGB classifier, because here we are solving a regression specific problem. So that's why we are using XGB regressor. Same thing will be applicable over random forest also. I hope you all remember. It is also applicable for both the kind of problems that it usually dealt with, whether it's a regression or a classification. It's just that for now we are dealing with the regression part. That's why we are calling regressor. One more important thing which you will see here is random step. By default, we're making it as 4-2, so that each and every algorithm will have same set of data points available. So here, next algorithm is gradient boosting, and then we just fit our model on the training set that we have. So now once this part is done, if you can see, let me remove this completely. And if you can see here, this is just data modeling. As I told you, initially I was trying to make, hyperparameter tuning via grid search CV. For that, we can, if you want, at your end, you can do one thing. As you have learned in XGB, we have the parameters of lambda, which is basically crucial as a, regularization parameter. Gamma, which is basically crucial for the pruning part. Maximum depth, learning rate, number of estimators, means how many number of XGB trees you want internally to execute. Same thing will be applicable for random forest and gradient boosting as well. Different parameters, whatever you want to set. First of all, you need to curate a dictionary for the same. And after that, you can call the model by the name of grid search CV. What is the estimator? What is the parameter grid? What is the cross validation part, scoring, everything you can mention here, and you can just fit your model on the training set that we have. And then you can just, examine what is the best estimator your model is giving as a gradient boosting part. And with the help of that best estimators which you are getting, you can do the predictions. But for now, I'm skipping this part. That's why I have commented it down. If you want to execute, what you're supposed to do, just uncomment this part. This code will run perfectly fine. But for now, what we are doing is we are just taking a vanilla algorithm here, where whatever be the configuration is given in the documentation, we are taking a default one. So let's run this model. And with this, within few minutes, our data modeling will be done. And finally, after that, maybe we can focus on the data prediction part. And in the meanwhile, you can see that just for the vanilla algorithm also it is taking time. So you can imagine that if I'm doing a recording, how much time it will take for me to execute this grid search CV wala portion. So please make sure you will do it on your own. Okay. Now I think this is done. What I'll do is I will now do model prediction, which is the next phase of our data pipeline. And here I'll just do one thing, model prediction. I'll just do the prediction of my model. And finally, at the very end, we will just do the model evaluation, where the next task is to evaluate the performance of all of these 3 models that we have, which is XGB, RF, and GB. We can print the values, and here initially I have tried to print for the grid search CV wala part as well, but for now it's not, I'm not focusing on that part. So here you can see with respect to the naive approach which we are doing, we are getting best results in terms of gradient boosting regressor, second best results in random forest part, and the last one is XGB. Now, it might be the case that if you will do a hyperparameter tuning, the results might get changed completely. I'm not sure. You can just try at your end. But this is how basically the complete end-to-end implementation of this XGBoost algorithm will be done. Depending upon what kind of algorithm you are using, you have to just call the corresponding function. Make sure at least if you cannot do all the hyperparameter tuning wala part, just make sure at least lambda and gamma you will take it very carefully. It should not be too much high value or too much low value, because it basically helps us to prevent the overfitting problem. And if you will just handle this perfectly, this will basically enhance the performance of your model part. So it's very important parameter in XGBoost, apart from number of estimators in the algorithms that we have. So I hope that this part is pretty much clear to everyone. And still, if you have any confusion, you can let me know. With this, let's end this module, and I'll see you all in the upcoming session. One thing again, I'm repeating, you can similarly implement the classifier as well. So that's why I'm not, showcasing you separately how the classifier works. It's just that you just have to change the method name, and accordingly you will be able to get the results. So depending upon what kind of problem you are solving, your function name will get changed. So don't cram anything. Try to understand things logically. Then only it will make sense to you. With this, bye bye everyone, and I'll see you all very soon in the upcoming videos.